Number 19, I'm asked to solve. Well, if I want to factor or apply the quadratic formula, the equation has to be equal to 0. So that means I need to move this 24 to the left side. So to move something from one side to the other in an equation, you use inverse operations. So because 24 is positive, I would subtract 24. If I do subtraction on one side, I have to do the subtraction to the other side. So subtract 24 from both sides. The left-hand side, I can't combine any of these three terms, so I'm just going to write it in standard form. 8x squared plus 4x minus 24, and that's equal to now 0. Now that it's equal to 0, I can see if I can factor this. If not, I would have to apply the quadratic formula. So before I apply method number 3 of factoring, I notice that 8, 4, and 24 have a common factor. I can factor out of 4. 4 divides all three terms. So if I factor out of 4, 4 times what would get me back to 8x squared, that first term, 2x squared. Bring down the plus sign, 4 times what would get me back to 4x and x. Bring down the minus sign, and 4 times what gets me back to 24, 6. Now that I factored out the greatest common factor, what's left in the parentheses, if you can still factor this, you have to continue factoring, and in fact you can. Multiply the first and last number, always write the positive answer, so that's 12. And I'm subtracting the numbers in my list. I'm looking for a factor pair 12 that subtracts to the middle term, which is a 1 this time. So the factor pair would be 4 and 3. How do I get one positive using 4 and 3? I would need a negative on the 3. So because there's a 2 in front of the x squared, we're going to have to factor by grouping. So this 4 on the outside that we brought out, the greatest common factor, we're going to ignore that for right now. All we're doing is factoring what's underlined in yellow. So factor by grouping says the first terms and last term stay the same, but the middle term gets broken up. So my first term was 2x squared. My middle term, instead of 1x, I'm using my two new factors in any order. 4x's minus 3x's would recombine as 1x, and then my last term stays the same, minus 6. Underline your two groups. From the first group, you're going to factor by finding the greatest common factor. Biggest number that divides 2 and 4 is 2. And they both share an x. What would be left in the parentheses? Well, 2x times what gets you back to 2x squared? X. Bring down the plus sign, and 2x times what gets you back to 4x? A 2. The sign that separates the two groups goes straight down. And from your next group, biggest number that divides 3 and 6 would be 3. And if my first parenthesis was x plus 2, my second has to match x plus 2. And I can always check by distributing the negative 3 to both terms. Negative 3 times x is negative 3x, and negative 3 times 2 is negative 6. So my two factors are, in any order, the matching parentheses is one factor, and the outside, if you kind of cross out the matching parentheses, the 2x minus 3 makes the second factor. So we just factored what was inside the parentheses, that yellow highlighted part. There was a 4 that we brought out, and this is still equal to 0. The 0 is actually on the other side, so I'm going to write equals 0. So from here, we're still not finished. We're trying to find the two solutions. Now that we factored it, we have to apply the zero product property. So I'm going to erase a little bit of work here, maybe on the side. So once I have my two factors, let me rewrite. I have 4 times x plus 2, and then 2x minus 3 equals 0. So from here, we use the zero product property, and we set each factor equal to 0. You can ignore the 4 in front because it doesn't have a variable attached. So I set x plus 2 equal to 0, and I set 2x minus 3 equal to 0. So for the first equation, subtract 2 from both sides, inverse operations. So my first solution is negative 2. My second, let me erase a little bit more here. My second equation, if I use inverse operations, add 3 to both sides, I get 2x equals 3. One more step in order to get x alone. Divide by 2. So my second solution here is 3 halves. So my two solutions are negative 2 and 3 halves.